Hello students, welcome back. Yesterday we have discussed what are numbers, classifications of numbers, what are prime numbers, how to identify if the given number is a prime or not. From today, we will start the chapter rational number. What are rational numbers? Any number which can be represented in the form of p by q is known as rational number. Any number which can be represented in the form of p by q are known as rational number, where p and q are integers and q should not be equals to 0. Any number of the form p by q where p and q are integers and q is not equals to 0 are known as rational number. For example, 2 by 3, minus 1 by 7, 3 by 4, 0, 7 upon 6 are the rational numbers. There are two conditions: p and q are integers and q should not be equals to 0 are known as rational numbers. Types of rational numbers. First type is positive rational number. Any rational number in which numerator and denominator are either positive or both negative are positive rational numbers. Any rational number in which p and q are both positive or both negative are known as positive rational number. For example, 2 by 7, numerator and denominator both are positive, therefore 2 by 7 is a positive rational number. Minus 3 upon minus 5, again numerator and denominator both are negative, therefore minus 3 upon minus 5 is negative rational number. Minus 1 upon 6, minus 1 upon minus 6, again both numerator and denominator are negative, positive rational number. 3 by 2, 1 by 8, minus 9 upon minus 10, etc. are the examples. Second type, negative rational number. A rational number in which p and q are both of opposite signs. A rational number in which p and q are both of opposite sign. If p is positive, then q should be negative. If p is negative, then q should be positive. For example, minus 2 by 7, 8 upon minus 3, 6 upon minus 5, minus 3 upon 4, etc. Minus 2 upon 7, numerator is negative, denominator is positive. 8 upon minus 3, numerator is positive, denominator is negative. Again, 6 upon minus 5, numerator is positive, denominator is negative. Minus 3 by 4, numerator is negative, denominator is positive. These are the examples of negative rational numbers. Basically, rational numbers are divided into two types, positive and negative. Positive, in which both are either negative or positive. Negative rational number, the sign of P and Q must be opposite. One is positive, then other should be negative. Next. Decimal representation of a rational number. Decimal representation rational number. Any rational number is of the form P by Q, that is numerator upon denominator. Numerator can be divided by denominator. Whenever we are dividing a numerator by its denominator, then we get some values. It may be integer, it may be natural number, it may be in decimal form. Suppose 1 upon 2. 1 upon 2 is 0.5. 4 by 2, that is 2, is integer. This is in decimal. 1 upon 3. 1 upon 3 is 0.333333. If we are dividing a numerator by its denominator, so we are getting either a terminating number, a terminating decimal, or an integer, or a non-terminating and repeating decimal expansion. Therefore, rational numbers are divided into two types. First is terminating rational numbers. What are terminating rational numbers? Terminating decimal expansions or terminating numbers. Numbers when a numerator is divided by a denominator. If we get an integer or a value which stops after certain digits, that is known as terminating. For example, 6 upon 3, that is 2. 10 upon 2 is 5. These are integers. Similarly, if 7 is divided by 10, then the value is 0.7, which terminates. If 25 is divided by 100, that is 0.25, terminates. That is 7 upon 10 is terminating rational number. 22 upon 100 is terminating. So here we can observe that if the denominator of a rational number, P by Q, if P by Q is our rational number, then if Q is in the form of 2 raised to the power m and 5 raised to the power n, then the decimal expansion of the given rational number is terminating. Then P by Q is terminating rational number. 10 can be split into 5 into 2. 100 can be written as 2 square multiplied by 5 square. If the Q denominator is of the form 2 raised to the power m, 5 raised to the power n, then the rational number P by Q is terminating rational number, where m and n are non-negative integers. M and n should be non-negative integers. M can be 1, 0, 2, 3, 4, any value. Similarly, n can take any value 0, 1, 2, 3, 4, 5. Let's take some examples. There are some questions we need to identify if the given number is a terminating rational number, terminating decimal expansion, or not. For example, 7 upon 2 raised to the power 3, 5 raised to the power 3. 5 upon 7 raised to the power 2, 2 raised to the power 3, 5 raised to the power 4. 6 upon 3, 2 multiplied by 5, 6 upon 5 cube. We need to find out if these numbers are terminating or non-terminating. Look, 7 upon 2 raised to the power 3, 5 raised to the power 3. Since the denominator is of the form 2 raised to the power m and 5 raised to the power n, therefore this rational number is terminating. Terminating decimal expansion. In this question is numerator is 5 multiplied by 7 square, denominator is 7 square, 2 cube, 5 raised to the power 4. If we observe only denominator, then there is 2 raised to the power 3, 5 raised to the power 4, there is some powers of 2 and some powers of 5, but there is 7 raised to the power 2 in extra. हमने क्या पढ़ा था? Denominator should be in the form of 2 raised to the power m and 5 raised to the power n. 7 raised to the power 2 extra है. But in numerator there exists 7 raised to the power 2. It got cancelled. So finally the denominator is 5 upon 2 cube, 5 raised to the power 4. इसको भी cancel कर सकते हैं. 1 upon 2 cube, 5 cube. Therefore, now final rational number, in final rational number, denominator is of the form 2 raised to the power n, 5 raised to the power m. Therefore, its decimal expansion would be terminating. Terminating decimal expansion. Next question. Again, observe the denominator 3, 2 square, 5. In numerator, there is 6, which is multiple of 3. This 3, cancel this 6 for 2 times. Therefore, 2 upon 2 square multiplied by 5. Again, from this 2, this one power get cancelled. Now, the final fraction, in the final number, final rational number, the denominator is of the form 2 raised to the power m, 5 raised to the power n. Therefore, the decimal expansion is terminating decimal expansion. Last question. In this question, numerator is 6, denominator is 5 cube. There is no power of 2 in here. This can be written as 2 raised to the power 0, 5 cube. 2 raised to the power 0 is 1, 0 exponent. Therefore, the denominator is of the form 2 raised to the power m, 5 raised to the power n. M and n should be non-negative integers. It can be 0. So therefore, this expansion should be terminating decimal expansion. This was all about terminating decimal expansion. Next is non-terminating decimal expansion. Non-terminating decimal expansion. What are not terminating decimal expansion? In any rational number, if the denominator is not of the form 2 raised to the power m, 5 raised to the power n, then the decimal expansion of that rational number is non-terminating. If the denominator of a rational number is not of the form form 2 raised to the power m, 5 raised to the power n, then the decimal expansion of the given rational number is non-terminating. In P by Q, in a rational number, P by Q, Q is not equals to 2 raised to the power m, 5 raised to the power n. For example, 5 upon 3, 7 upon 3 cube multiplied by 11, 7 upon 11 square, 13 cube, etc. Again, there are some questions we need to check if the numbers are terminating or non-terminating. Three upon 5 upon 3, sorry. When 5 is divided by 3, then we get 2.666666. This 66666 would be repeating, would be non-terminating. It can be written as 2.6 bar. Whenever a digit is repeating for more than one time, then we can put a bar on this on that particular digit. So 5 by 3, the denominator is 3, which is not of the form 2 raised to the power m, 5 raised to the power n. Therefore, this number is, the decimal representation of this number is non-terminating and repeating. There are more examples. 50 divided by 11. When 50 is divided by 11, perform a division. 11 fours are 44. Remainder is 6. Decimal 0. 11 fives are 55. Again, remainder is 5. Put 0. 11 fours are 44. 6. 0. 11 fives are 55. Again, remainder is 5. Put 0. 11 fours are 44. Again, remainder is 6. Again, put 0 5 times, 55. Remainder is 5. This process will be continue. The quotient is 4.545454, and it's repeating and non-terminating, which can be written as 4.54 bar. As we can see, if the denominator is not of the form 2 raised to the power m, 5 raised to the power n, then the decimal expansion would be non-terminating and repeating. If there is any other prime number other than 2 and 5 in the denominator, then the decimal expansion would be non-terminating and repeating. Let's move on to the next topic, that is representation of a rational number on the real number line, representation of rational number on number line as we have studied that rational number is a real number which represents any real physical quantity. Any real number can be represented on the real number line, on the number line. Similarly, any rational number is a real number, so it can be represented on the number line. What is number line? First, what is number line? A number line is a normal line in which we consider 0 at the middle. In right side of 0, there are positive integers and on the left side of 0, there are negative integers. Any value which is any number which is greater than 0 will lie on the right side of this number line, and any value which is less than 0, which is negative, will lie on the left side of this number line. Now we have to represent a rational number on this number line. For example, 3 upon 5. 3 upon 5 is a positive rational number. Both numerator and denominators are positive. Therefore, it will lie in the right side of 0. We have to represent this 3 upon 5 on this number line. First method is you can solve this in decimal form, then put it here. Second form is we can directly plot it here on number line. 3 upon 5. First, observe the given number. Since the numerator is less than the denominator, if it is equals to P upon Q, where P is less than Q, P is less than Q, Q is greater, denominator is greater. Therefore, this number lies between 0 and 1. Since it is positive, so it will lie on the right side, and it is denominator is greater than numerator, therefore it lies between 0 and 1. So first we know that we have to put this number between 0 and 1. Let's make another line. Here is another number line. 0, minus 1, and this is 1. And in between 0 and 1, we have to put this number 3 upon 5. Now, step number 1. What is our denominator? Denominator, Q is 5. Q is 5. 5 minus 1, that is 4. Draw 4 small lines between 0 and 1. 1, 2, 3, 4. These small lines should be at the equal distances. 1, 2, 3, 4. Each line represents a part. First part, second, third, fourth, fifth. So we have divided 0 to 1 into 5 equal parts. Now we have to represent 3 upon 5. The numerator is 3. Third line is from 0. Count the third line. 1, 2, 3. This third line will represent 3 upon 5. So this is our representation of 3 upon 5 on the real number line. One more example. Let's take 7 by 3. We need to represent 7 by 3 on the real number line. Now, numerator is 7, denominator is 3. Numerator is greater than denominator is equals to if P by Q, and P is greater than Q. Whenever the numerator is greater than denominator, we can solve it in mixed fraction. We can convert this fraction into mixed fraction, this rational number into mixed fraction. Seven upon 3. 7 upon 3 can be written as 2 and 1 by 3. 3 2s are 6 plus 1 7, 7 upon 3. So 7 upon 3 can be written as 2 and 1 by 3. Whenever the numerator is greater than the denominator, convert it into mixed fraction or mixed number. Now the number is greater than 2 and less than 3, therefore and positive. Therefore it lies on the right side of the 0 and between 2 and 3. Let us draw the number line. -1, 0, 1, 2, 3. We have to represent 2 and 1 by 3 on the number line now. So number will lie between 2 and 3. 2 and 3. Now the denominator is 3. 3 minus 1 is 2. We have to draw two small lines at the equal distances. So from 2 to 3, this section is divided into 3 equal parts. Now numerator is 1, therefore the first line will represent 2 and 1 by 3 on the number line. Number is greater than 2, less than 3, in between 2 and 3, this is 2 and 1 by 3. Next example, let us represent 4 upon 5 on number line. -4 upon 5, -4 upon 5. Numerator is negative, denominator is positive. Therefore, this rational number is negative rational number. Negative values or negative rational numbers lie on the left side of the 0 on number line. Zero, 1, -1, -2. -4 upon 5. Since the value is less than 1 or less than -1, it lies between 0 or -1. In between -1 and 0, this value will lie. Denominator is 5. 5 minus 1, 4. Draw 4 small lines between 0 and -1 at equal distance. 1, 2, 3, 4. There are 4 equal lines. 4 lines at equal distance, which divides 0 to -1 into 4 equal parts. Now numerator is 4. Count 4 from 0. 1, 2, 3, 4. This is 4th line. From 0 you have to start. 1, 2, 3, 4. 4th line will represent -4 upon 5 on number line. Another example. Let's represent -17 upon 5 on number line. -17 upon 4 can be simplified as -3. 5 3s are 15. Remainder is 2. 5 3s are 15 plus 2 17. -17 upon 5 can be simplified as -3 2 by 5. Therefore, this number will lie between -3 and -4. Since negative rational number will lie on left side of the 0 and number is greater than -3, number lies between -3 and -4. Draw lines. Number line 0, 1, 2. On the left side -1, -2, -3, -4. Number will lie between -3 and -4. Denominator is 5. 5 minus 1 is 4. Divide this section into 5 equal parts by drawing 4 lines at equal distances. First line 1, 2, 3, 4. Now numerator is 2. Count second line. minus 3, then first line is 1, 2. This is second line. This second line will represent minus 3, 2 by 5 on the number line. One more example. Represent minus 8 upon 3 on number line. First, minus 8 upon 3, numerator is negative, denominator is positive. A negative rational number will lie on the left side of 0. Minus 8 upon 3 can be simplified as minus 2, 2 by 3, 3 2s are 6, plus 2, 8, 8 upon 3. That is minus 8 upon 3 can be written as minus 2 and 2 by 3. Here's the number line 0, 1, 2, minus 1, minus 2, minus 3. The rational number, negative rational number, will lie between minus 2 and minus 3. Denominator is 3. Therefore, divide this section into 3 equal parts by drawing 3 minus 1, 2 lines at equal distances. Line number 1, line number 2. The numerator is 2. Therefore, second line 1, 2. Second line will represent minus 2 and 2 by 3 on number line. One more example. Represent 15 upon 7 on number line. 15 upon 7. Both numerator and denominators are positive numbers. Therefore, the rational number will lie on right side of 0. 15 upon 7 can be written as 2 and 1 by 7. 7 2s are 14 plus 1 15. 15 upon 7 can be simplified in the form can be simplified as 2 and 1 by 7. Zero, minus 1, 1, 2, 3, 4. The number is greater than 2 and less than 3 will lie between 2 and 3. Two and 3 on the right side of 0. Denominator is 7. Divide this part 2 to 3, this part into 7 equal parts by drawing 7 minus 1, 6 lines at equal distances. 1, 2, 3, 4, 5, 6. Now the numerator is 1. Therefore, first line counting from 0, counting from 2, first line, that is this line, first line will represent 2, 1 by 7. So these are the examples of representation of rational number on number line. Positive numbers, positive rational numbers, negative rational numbers whose values is between 0 or 1 or 0 or minus 1 and whose values are greater than 1 can be represented in this form. Thank you.